Now let's move over to the payoff phase, or the NADH and the first ATP generation. So we now have glyceride triphosphate. Let's recap. First is glucose is converted to glucose phosphate by what? By an enzyme known as hexokinase or glucokinase by taking ATP molecules to ADP. Second step is glucose phosphate is converted to what? To fructose phosphate by phosphohexoisomerase, and fructose phosphate is converted to fructose 1,6-bisphosphate by an enzyme known as phosphofructose kinase type 1, and fructose 1,6-bisphosphate is converted to dehydrogen acetone phosphate and glyceride triphosphate by an enzyme known as what? Aldolase. Then dehydrogen acetone phosphate is converted to what? Glyceride triphosphate by triose phosphate isomerase. Dehydrogen acetone phosphate is converted to glyceride triphosphate by triose phosphate isomerase. Now we have glyceride triphosphate. Glyceride triphosphate is now converted to 1,3-bisphosphoglycerate, which is done by an enzyme known as glyceride triphosphate dehydrogenase. Observe something. You can see two here, you can see two here, you can see two here. Remember that I told you, instead of us having one glyceride triphosphate, we now have two, because the dehydrogen acetone phosphate is converted to glyceride triphosphate by an enzyme known as triose phosphate isomerase, because our body cannot go and produce pyruvate from the hydrogen acetone phosphate. Our body can only produce pyruvate by converting this glyceride triphosphate to so many other substrates. And second thing I want you to know is we are converting what? We are converting NAD positive to what? NADH. So some people start asking me, what is NAD positive and what is NADH? NAD, the full name is what? Nicotinamide adenine dinucleotide. Nicotinamide adenine dinucleotide. Nicotinamide adenine dinucleotide. So the NADH, that means the reduced form of nicotinamide adenine dinucleotide. So nicotinamide adenine dinucleotide is the oxidized form, and NADH is not the reduced form. So what are these NAD positive? This NAD positive, which is nicotinamide adenine dinucleotide, what are they doing? They are in our blood. They serve as public transporters. Example, when you are moving from a junction to a junction, or from a place, so consider an aerospace or an aeroplane. So what is happening when you are trying to move from one country to another? The aeroplane is just to carry you from a country to another country, from country A to country B. So that is what is also happening in NAD positive. Their function is just to transport hydrogen ions and 2 electrons. So they serve as transporters in the cell. What they do is to convert, is to transport. So after transporting, they return back to the original form. So where are they transporting it to? They are taking all these molecules, they are taking all these substrates to the matrix of the mitochondria. They are taking them to the mitochondria to now deposit them there, which will now undergo the electron transport chain to produce energy. Just what you have to have in mind is NAD positive, or the NADs, they just serve as transporters. So what are they doing? They are taking hydrogen ions and electrons, and they are depositing them to the mitochondria, and they are returning back to their original form. So what are they taking? The NAD positive. The NAD positive will come and take 2 electron plus what? Hydrogen ion. So what are they doing? They will go to the mitochondria and what are they going? They will now form NADH. So what are they doing? They will now go to the mitochondria to deposit them. So they're going to the mitochondria to deposit this hydrogen ion and 2 electrons. So it just serve as an aerospace or aeroplane. What they're just doing is they are taking these hydrogen and electrons and they're taking it to the what? To the mitochondria. Now we have glyceraldehyde triphosphates dehydrogenase. So anytime you hear the word dehydrogenase, what are we doing? We are taking NAD positive and we are converting it to what? NADH, or we are taking NADH and we are converting it to what? NAD positive. So that word glyceraldehyde triphosphate dehydrogenase means we are converting glyceraldehyde triphosphate to 1,3-bisphosphoglycerate. I hope these two will not be confusing anymore, because I said there are two because dehydrogen acetone phosphate is converted to what? Glyceraldehyde triphosphate. Now, from glyceraldehyde triphosphate, we now convert to 1,3-bisphosphoglycerate. Another enzyme called phosphoglycerate kinase. Now, when you hear kinase, what is coming to your mind? We are always converting ADP to ATP, or we are converting ATP to ADP. So this is the payoff phase. So what are we doing? We are converting 1,3-bisphosphoglycerate to 3-phosphoglycerate by doing what? By converting ADP to ATP. So remember, we have 1,3-bisphosphoglycerate and we have 2 phosphate group. So whenever you see this means a phosphate. So we have 2 because this glyceraldehyde, they are 2 molecules. Since there are 2 molecules and we are trying to convert this glyceraldehyde triphosphates to 1,3-bisphosphoglycerate, what will now happen is we now need 2 phosphate group. How? So let's say this is our glyceraldehyde triphosphates and this is our glyceraldehyde triphosphates. So to convert this to 1,3-bisphosphates, how many phosphates are we going to add? I'm going to add 1. We are moving from glyceraldehyde triphosphate to 1,3-bisphosphoglycerate. So I'm going to add 1, and when I add 1, I will now have what? 1,3-bisphosphoglycerate from this what? Phosphate molecule. And when I have 1, remember I added how many? 1 phosphate group here. And I'll now add another what? Another 1 phosphate group here, because there are 2 molecules inside this glyceraldehyde triphosphate. So total of how many phosphates am I adding? I'm adding 2 phosphate group. So since I'm adding 2 phosphate group, that's how we have what? These 2 phosphates there. Now in this 1,3-bisphosphate glycerate, what are we doing? We are now converting them back to what? Phosphoglycerate kinase. Phosphoglycerate. What are we doing? We are taking NADP and we are converting it to what? ATP. Remember, this is 2 molecules. This 1,3-bisphosphoglycerate, that is how we have this times 2, because there are 2 molecules. Now, since there are 2 molecules and there are 1,3-bisphosphoglycerates, what will now happen? To convert them to 3-phosphoglycerates. So for me to convert this molecule to 3-phosphoglycerates, and enzyme known as phosphoglycerate kinase will act on them. So what will now happen? First, I will take ADP molecule, and what am I doing? I will now come and convert them to what? ATP. And what is another thing I will do? I will also come here and take ADP molecule, and I will also come and convert them to what? ATP. And as soon as I done this, what will now happen? I converted 1 ADP to 1 ATP, which is here, and I converted plus another 1 ADP to 1 ATP, which will now give us what? 1 plus 1 is equivalent to what? 2. That is why you see 2 here. We are converting 2 ADP to what? 2 ATP. They are 2 because there are 2 molecules. Please understand that. And which enzyme is using that? Phosphoglycerate kinase. So let's recap everything we have done. From glucose 6-phosphates by enzyme known as hexokinase, from glucose to glucose 6-phosphate, which is hexokinase or glucokinase, from glucose 6-phosphate to fructose 6-phosphate by phosphoglycerate, from fructose 6-phosphate to fructose 1,6-bisphosphate by phosphofructose kinase type 1, from fructose 1,6-bisphosphate, an enzyme called aldolase now convert it to what? Dehydrogen an enzyme called aldolase now converted to dehydrogen acetone phosphate and glyceraldehyde 3-phosphate and glyceraldehyde 3-phosphates, and another enzyme known as glyceraldehyde 3-phosphate dehydrogenase now convert this glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate. Another enzyme known as phosphoglycerate kinase now convert them to what? 3-phosphoglycerate. Now, in this